Hello again, physicists. Today I have a presentation for you introducing our new topic, which is circular motion. To begin, what really is circular motion? Well, it will be any sort of motion where an object is traveling in a circular path. Some examples of circular motion could include special cases where a satellite is in orbit around the Earth. It could be a car making a turn around a curve, or there are several amusement park rides like roller coasters, teacups, yo-yos that also show circular motion. So there are many different ways in which circular motion can be perceived in everyday life. We are going to start off this unit by just doing one simple thing, and that is learning how to determine the velocity of something that is moving in a circle, given that the magnitude of the object's velocity is constant. And when we look at circular motion in this particular class, the magnitude of the object's velocity will always be constant. And the only thing about the velocity that will be changing is the direction part. So if I wanted to give this particular object up here, this little black dot, a velocity of 1 meter per second, I am saying that as that dot travels around in a circle, it will always have a velocity of 1 meter per second. How can we calculate what that velocity is? Well, if you recall, when we did one-dimensional kinematics, we could say that the velocity of an object, should it be constant, is equal to the distance the object travels divided by the time it takes for it to travel that distance. Now, if we look at the circle, I am tracing out a very specific path that the object would be traveling. This is the outside of the circular path, also known as the circumference. So in circular motion, if we want to find the velocity of an object, the distance will be the circumference of the path, or the circle. And we know from math class, hopefully, that the circumference of a circle is 2 pi times the radius of the circle. So we can plug that in for distance, and this is what we end up with. That the velocity of an object going in a circle will be 2 pi times the radius of the circle, divided by the time it takes to complete one full circle. And this time will often be referred to as the period, which is the amount of time it takes to complete one full cycle of motion. In this case, a cycle would be a circle. So if I wanted to say that the period of this particular circle up here was 1 second, what that means is that it's going to take 1 second for one full circle to be traveled. It'll take 1 second for this object to go around in a complete circle. So just know that a period is just a special type of time it takes to complete one full cycle of motion. Be ready to have a warm-up related to this concept tomorrow. And until next time, physicists, until next time.